Hello all. Welcome back to this 7th session of this 9-part series on JavaScript object-oriented techniques. In this particular session, we'll be looking at how to provide and how to improve performance in JavaScript, ensuring that the user do not have to wait for too long UI updates and a bad user experience. So let's start. The performance impact of JavaScript or UI is generally considered as negligible, but still there are some things that we shouldn't do in order to make the user get a good user experience. This is a general view in which our browser works. Whenever a given JSP or a view page is getting rendered. So what happens is there are two components in browser called as UI thread and UI queue. UI thread is the current running process in the browser, whereas UI queue is the waiting threads in the browser. The UI thread executes sequentially, that is, after every UI update a JavaScript is executed, and that is executed in sequence until the next UI update, which is waiting in the UI queue, comes in. So UI update, by UI update what I mean is the changes in the colors or the changes in the layout, and by JavaScript execution what I mean is any processing done on the client side, be it a validation, be it a computation or anything. So once after the JavaScript is completed, the UI update which is waiting in the UI queue is moved into the UI thread for execution. So if you have your JavaScript taking too much time for execution, then it becomes an unresponsive UI, because as seen in the previous slide, your UI update is waiting for your JavaScript to complete, and if your JavaScript takes too long time to execute, then your UI update only happens after a few seconds, giving the user a bad user experience. So in general, there are some 3 to 4 spots in JavaScript that we can concentrate on how to improve the performance in. So one of them is the load time techniques. So what happens is, given a page, be it a JSP or any other viewing technology, it will request for JavaScript files, and during its request the other UI updates are kept in pending state until the complete file is rendered to the browser from the server side. So let us take a look at what exactly happens when a JavaScript file is requested for from a view page, be it a JSP or any other file. So this is a small snapshot of what happens on the browser side whenever a JSP requests for a given JavaScript file. So UI update is the first thing that happens in case it is the first execution that is performed by the browser, and whenever a JavaScript file is requested by a browser or a given page, there are 3 phases that are performed on behalf of it. They are download, parse and execute. Download is the phase which actually downloads the page from the server side to the client side. So once the particular JavaScript file that is requested for is downloaded, it is parsed and executed. and until that execution completes, your UI update which is waiting in the UI queue do not execute. So these are the three phases that happens in the JavaScript whenever a JavaScript file is requested from a JSP. Observe that in these three phases, the download time is the dynamic time. That is, depending upon whether the browser has already cached the contents of the JS on its site, or if this is the first time that it is ever requesting from the server side. So depending upon it, the download time varies, because the browser may have already cached if this was not the first request, or if this is the second or the third request, then it may use whatever the contents that was cached in during the first time request, and then the passing and the execution time remains constant. So the only variable time is the download time. Okay. So we can observe what is the thing that we can do to improve performance in here. There are various techniques that can be used to improve the performance during the load time of a JavaScript. So put scripts at the bottom, combine the JavaScript files, load scripts dynamically, defer scripts, asynchronous scripts. So let us look at each of them one by one. So let us go back to the earlier example itself. Let me create a new file. There is some problem in here which is not making the script to execute. Okay, alright. So, and in this case you will see that loadtime.html is requesting for loadtime.js file and any of the UI updates. So let us take, for example, I have a simple text. So in this case you will observe that text 1 is getting loaded on the backend, and then your alert is coming, and then your text 2 is coming on the backend. So which means to say that your HTML waits for the loadtime.js to be loaded on the browser side and only then continue with its UI updates. Okay, so what is the drawback with this approach? Okay, so what if I put this same requisition of the file on the backend, which means to say that you will see that text 1 and text 2 are already loaded on the browser and your alert comes after doing all the UI updates, which means to say that your user will have a better user experience because he is already ready with his elements to operate it with. So this is one of the techniques in which we put our requested JS file at the bottom of the JSP file or HTML file that we are requesting for. So this happens to be the first approach. Combining JavaScript files. Your JSP or HTML, whenever it has requests for multiple JS files, what happens is there are multiple HTTP requests that are made to the server side to ensure that all the files are rendered to the browser. Now this is a bad idea. Instead of having multiple HTTP requests, what you could do is better to have all of them compressed into a single file, and that compressed file is the only file that will be requested by your HTML file or your JSP file. So by doing so, you have only one HTTP request to the server side, ensuring that the turnaround time for the same is reduced. So let us look at the other three approaches which improve the performance of JavaScript loading to the browser. Load scripts dynamically. A small example of this could be so in this case I have my UI updates here and I have a script element. I'm creating a script element. I'm assigning the type and I'm assigning the source to it, and I'm inserting it to the document model. Now in this case, one of the advantage of this approach is that it is asynchronous. That is, it does not block your UI updates that are happening on the browser. It is a separate cycle. It happens on the network thread. So so that's a dynamic approach. Downloads no longer block the UI thread. So what is this in comparison with our earlier slide? So what happens is, in this case, whenever we are trying to load a JavaScript file dynamically, after your first UI update, your JavaScript, which is having three phases, download, parse and execute, in this case your download and parse happens on a separate thread. It does not happen on the UI thread. And once the downloading and the parsing is completed, your execution happens on the UI thread. Okay, so downloading and parsing happens on the network. So what happens is, until your download and parse is not completed, your UI update, which is waiting on the UI queue, need not wait anymore. It can concurrently execute on the UI thread. So once your download and your parsing is completed, execution of the JS file happens on the UI thread. Now this is the flow with the dynamic loading of script files. Defer is another thing which is also very similar to the loading scripts dynamically, because given defer scripts do not execute on the UI thread. That is, the first two phases of the JavaScript dynamic loading, which is downloading and parsing, happens on a separate thread called the network thread. So the UI thread is used only for the execution of the JavaScript file. Again, here your UI update need not wait for the downloading and parsing phases of your JavaScript files. Only it will execute concurrently again here with your downloading and parsing, and execution happens once your parsing of the JavaScript file is completed. Okay, so then what is the difference between loading scripts dynamically and your defer attribute? In a defer case, in load time scripts, okay, execution in your load time, when you're trying to load your JavaScript file dynamically, your execution of the JavaScript file happens immediately after the downloading and the parsing is completed, whereas that is not the case with the defer scripts. With the defer scripts, your execution is postponed until all of the JavaScript files have been downloaded and all the UI updates are completed. Only as a last phase is what execution of all the deferred scripts is performed. So that happens to be the difference between the defer scripts and the load time scripts dynamically, because your load time scripts are executed as soon as the JavaScript file is loaded and parsed, whereas that is not the case with the defer. It will wait until all of your UI updates are executed, and it will execute the JavaScript files as the last phase of the page execution. So let us take a look at the defer, how to specify the defer attribute for HTML files which are trying to import a JS file. In this case, hello world and your message that is following the script tag will be executed immediately, and your defer and your JS file will wait until all the UI updates are executed, and as the last phase it executes even the foo.js. Now another thing to be noted when having multiple defer scripts is the order of execution. When you have multiple defer scripts is unknown. This is also something to be taken care of when you code for it. Next is asynchronous scripts. This is very similar to the dynamic scripts. That is, execution happens as soon as the JavaScript file is loaded and parsed in the browser. And for using async, you will specify an attribute called async on the script tag. So this should be enough for you to import the JS file dynamically into the browser or into the HTML file, and your asynchronous element will indicate that the execution of the scripts need to happen immediately once it is loaded into the browser and parsed. So asynchronous scripts is very similar to load scripts dynamically. Only difference is that you will have to manually code in the case of load scripts dynamically, whereas in the case of asynchronous scripts it will be loaded just by specifying the attribute at the script tag. So this is whatever we have discussed until now is with respect to download times of a JavaScript file. Now we can take a look at how to improve the runtime techniques of a JavaScript file. That is, how to improve a JavaScript execution code. So let us take a look at a long running process in JavaScript and how it could impact the performance. So in this case, I have a process array which could be called by any external API, and this takes items, process and callback. Now in this case, if you observe, it iterates through the items and it invokes the process method on it, and then after completion of all of them it does the callback function. Now imagine if the same items is there are 1,000 records in the items array. So then what happens is the execution of this process array is too long, and your UI update, which is waiting in the UI queue, takes too long to happen. So what we should do is to somehow split out the work such that your UI updates is concurrently happening or simultaneously happening along with your JavaScript execution. Okay, so let us see how we could achieve that. Your set timeout method is a nice tool for you to split out your work, wherein you say that a specific set of codes need to be executed after some set of milliseconds, and in this example 500 milliseconds. So what you could do is basically split out your work. In the previous example, if you could see, you have multiple set of array that is containing multiple set of data. So you could split out your data into 2 pieces or 3 pieces and then execute each piece after a set of milliseconds, ensuring that you give space for UI updates to happen on the browser. Ensuring that the user is having a better user experience. So this is some process on how you could achieve the same, wherein you specify 25 milliseconds and you have your set timeout method doing the actual processing of the past object. Another approach which is yet to be released in ECMAScript is the set immediate, and that is about to be acknowledged by all the browsers. So let us take a look at how it is going to work. It is actually going to work very similar to the set timeout, but what happens is it will wait for any of the process. If there is no execution that is happening on the UI thread, then set immediate executes immediately. This is the purpose of set immediate. It does not wait for your specific milliseconds, as in the case of the set timeout. You will have to specify a specific time after which the code execution in the JavaScript continues. Unlike that, in set immediate you will specify the code that you want to execute in chunks, and the set immediate will wait for the next a space in the UI thread to execute, and as soon as it is available, it executes. It does not wait for a specific time. This is the advantage, and this is the actual implementation that you could use to execute a specific set of process immediately. Web workers is the third technique that you could use to optimize your running of execution on the browser side. We could see a live example of it. So in this case, I have my worker.html file. Okay, firstly, to explain what is worker process or the web workers are nothing but the establishers of the thread concept, which is another object-oriented programming languages in JavaScript. In JavaScript for threads, it is web workers. So in web workers, you will see that you will instantiate an object of worker object, passing it a JavaScript file, which is in many terms a thread, a JS file which represents a thread. And then what you have is a callback function and your post message function. So let us see on how it works. So worker.post message, whenever you invoke this, your JS file's self.on message is invoked, and your self.on message accepts this argument, whatever that is sent by the post message, and it processes the data. After processing the data, it calls the post message on self object, and on self post message invocation, your callback function, which is on message, is called, and hence indicates that the processing of the data is completed asynchronously, that is as a thread, that is simultaneously with other executions of the JavaScript processes. So let us take a look at how exactly it works. So let us remove this for loop. So in this example, you will see that your worker sample.js, after processing the data that is sent to it from worker.post message, is passing the same data to the callback function here, and your callback function prints it to the browser. So in this case, we may say we get the output of the program. So if you want, you can change this data. It accepts a JSON string. That is something to be observed. So I change it to 45, change it to 45. Still I get the values on the browser, 4545. So this is something like a process that could be used for spawning multiple threads on your browser side. So in this case, if I add my earlier code, which is having a for loop, your browser does not throw the exception that the script is taking too long time to execute. Whereas if you don't, because this is executing in a thread. So if you don't have this kind of a structure and you still have a for loop, so let us see what happens on the browser side. So let me have this code right here. So let me see what happens on the browser side when I have a code like this. It gives you a message telling that the script is taking too long time to execute. So instead of that, we could have it as a thread. So in the case of the web workers, you don't have access to any objects that are exposed at the window level or document level. You cannot alert for input data or any kind of data after processing or before processing. It does not block UI updates. So the examples in this we have already seen. So now that we have covered both the techniques on how to improve the load time techniques for JavaScript files and how to improve the execution of the JavaScript itself, we now take a look at how repaint and reflow on UI, what are they and how to improve the performance over there. Repaint and reflow are two separate processes that happen on the browser side whenever the UI is rendered. Repaint is very similar to changing the color of a text box, changing the texture of a text box, whereas reflow has got to do more with the layout of the components in the browser. So as clearly seen, repaint takes much lesser time to execute in comparison with reflow, which takes much more time to execute on the browser side. Repaint is very similar to changing colors or background images. Reflow occurs in the following scenarios: initial page load, browser resize, DOM structure change, layout style change, layout information retrieved. Initial page load: whenever a page is loaded into the browser, you need to perform a reflow to accommodate all the components of the view. Browser resize: after the page has been loaded, if you minimize or maximize, you should have to resize each and every component. You should have to reflow each and every component on the browser so that it fits it makes everything smaller or bigger. DOM structure change: any element that you add, any element that you remove, or any element that you hide, all these are participants of a reflow. Layout style change: layout style change is very similar to changing width or height of a component on the browser side. Layout information retrieve: whenever you retrieve, this is something that needs more explanation, which I'll be explaining in later sections. Whenever that you try to access any computed properties of a particular component, then your browser reflows, computes every single component, and then arrives at the computed value, and then it will give you back the value. So now let us take a look at various approaches on how to improve the performance impact given by reflow or repaint. There are 3 to 4 techniques that we will be discussing in here. So one of them is perform your DOM manipulations of the document. So what you could do is you could use a document fragment. You could use a document fragment in this case. Now let us take a look at document fragment. This is my list, which is items as fetched in here. I create a document fragment out of it, out of my document object, and then I have an iterator which iterates through 10 elements and creates li elements which are appended to the fragment. And then to the list that we have already accessed, we append the child of the fragment. Now let me explain in detail what happens and what could have been the earlier code. So in general, instead of fragment dot append child of item, we generally append the child elements to the items element itself. Something like list dot append child. This could have been the code. Instead of the fragment, we could have had, I think, something like this. So in this case, whenever you are appending a given child to the master element list which is associated with the document object, on each occurrence of this there is a reflow which impacts performance. Now reflow for one item into 10 items in this case causes 10 reflows on the browser side, which is performance impacted. So what we could do is to go with an approach wherein we either remove the element out of this document and then we append the child and then finally add it back to document, which causes something like a code like so. In this phase you are removing the list element and then using the list element you are appending the childs, and then what you do is document dot append child of list. Now in this case, though you're doing the same actions, you're removing and adding it back to the document object. So what happens in this case would be, though there are iterations to append childs into the list element, no reflow will be performed during this case. Instead, only reflow that happens is during document.append child of the list. So this performs 2 reflows to the system. In fact exactly 2 reflows, because document dot remove element itself is a document structure change, DOM structure change. So that is one reflow, and your second reflow happens on document dot append child of the list when you're putting back the list into the system. So these are 2 reflows. A much better approach than this will be when you use a document fragment. So let us take a look at how exactly that is performed. So in the case of the document fragment, you create the document fragment out of the document object and keep it aside, and using it you will append childs, whatever the childs that you want to append, and then you add back or add it to the list that is there in the document object model. Now in this case you have performed only one reflow, that is dot append child, unlike the case where you remove and add back, which will cost two reflows, and in this case you will have only one reflow. This is much better approach. And for your information, document fragment is a separate object. It is not associated with the document itself once it is created. So on calling append child on the fragment, there won't be any reflows happening on the system or on the browser. And when you call this dot append child of this fragment, the browser takes the child elements of the fragment object and then appends it to the list. Unlike the usual convention of appending this fragment itself to the list, what it does is appends the children of the fragment object to the list. That is the traditional approach. And that happens to be the best approach of using a document fragment in the system to avoid multiple reflows. These are some of the approaches wherein you set your display to none and make changes, and display back to default. Modifying the visibility attribute causes repaint, whereas setting display to none and setting back to default is a reflow. So this approach on the earlier case, what we could do is, instead of removing it, we could have something like list.style.display none, and after that, after appending all your elements to the list, what you do is to set back the display to the block, which is the one that displays the list. So in this way, set elements display to none, make changes, set back to default. Modifying the visibility attribute causes repaint, whereas setting display to none and setting back to display default is the reflow. So this causes only one reflow on the system. In fact, in this case also there will be two reflows, as the display was made none and was made back to block. So in this case also you have two reflows on the system, on the browser. So document fragment, we have already seen it, what exactly it is. Technique 2 will be to group style changes. Now what do I mean by group style changes? In this case, you will observe that I have an input element. I access it using the general convention, and then I assign various properties to it. The color, the height. So in the case of color it will be a repaint, and in the case of height it will be a reflow, and in the case of the font size it will be a reflow, and in the case of the background color it will be a repaint. So there will be two reflows, two repaints, causing the browser to perform very slow when you have this kind of a structure. Instead of this, you could have a structure wherein you have your class. You define a class with all the specific properties and you specify the class name to the element. By doing so, you have only one reflow taking care of all the actions that needs to be performed. So, very similar are inline changes, wherein instead of having it as a class, you specify it as a CSS text, the complete set of properties. In this case also it will be a single reflow on the browser. So these are some of the changes, some of the approaches that you could take down when coding on the browser. And I always used to be thinking that having classes in the CSS style sheets is only the way of organizing your style sheets, and this was the first time that I ever am telling that this is also a technique to improve the performance on the browser side. So whenever you try to access any of the properties of the elements which start with offset, it means that there will be a complete reflow happening on the browser. Offset indicates that the desired value will be a computed value from the browser. So there are many properties starting with offset, and so whenever this is done, whenever that you try to access offset property of an element, the browser will perform a definite reflow, and only then it will give you back the value. So don't access the offset unless and until really required for you to do so. There are multiple properties starting with the offset, scroll top, client top. All these are computed values. Yes, there are two techniques that you can take a look at, which are data URIs and CSS sprites. Data URIs are much better performant in comparison with CSS sprites. So the current trend is to go with the data URIs. WebKit Sun Spider is one way that you could compare the browser results on the various JavaScript executions. Thank you. This ends the current session on the JavaScript object-oriented techniques. Keep in touch with the rest of the slides. Thank you.